Hello and very welcome everyone to this session of the World Geography Internal Structure of the Earth. In today's session, we are going to discuss this topic and we'll see what we can learn. So let's start. Before we start, the images, text, and other materials used in our presentations are for educational purpose only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the same. So first, let's just see what we can learn about this topic. So scientists have some sources of information about the interior of the earth. They are as follows. So when we discuss about the interior of the earth, so we cannot see directly into the interior. We can just take a assumption with the help of some seismic waves and all that. So let's see that what the scientists have observed so far. So first source is the direct sources, then the volcanic eruptions and rocks from mining area. So these are the source of information about the interior structure of the earth, that what happens inside the earth and what are the phenomena that helps in understanding this thing. So these are the three types of sources which makes us understand about the internal structure. Indirect sources: by analyzing the rate of change of pressure and temperature, scientists have a fair idea about the interior of the earth by absorbing the rate of change of pressure and temperature from the surface towards the interior of the earth. So scientists have observed the pressure and temperature a lot of times, and when they see the things in the rate of change about the pressure and temperature, they get to know a lot about the interior structure, that what happens with the depth, how the temperature and pressure changes according to the depth. So that is all being done under this point. Then gravity anomaly. So gravity anomaly gives us fair information about the material in the earth's interior, in which scientists measures the changes in gravity value according to the mass of material. By analyzing the meteors, scientists also analyze the material of meteors because they belongs to the same type of material earth is made of. Then seismic waves. Earth's gravitational forces are greater near poles and less at the equator. By the help of variations of the gravitational forces, scientists have been able to determine a fair idea about the interior of the earth. So apart from the gravity, about the material, that how the material works according to the gravity that is working inside the earth, and apart from learning about the meteors, that how the meteors basically works, now another important information that we gather from the type of energy or waves is are called seismic waves. And by analyzing these seismic waves and the variation by the scientists, we get a fair idea about the interior of the earth. Magnetic sources, seismic waves. So with the help of seismic waves or primary and secondary waves, scientists research about the state of material in the interior of the earth. So basically, if we talk about the seismic waves, so every seismic wave travels at a different distance. Like primary waves can travel throughout solid, liquid, gas. Secondary waves can travel through only solid and liquid. And while if we talk about the L waves or the Rayleigh waves, they are the destructive waves and they travel on the surface only through solid and liquid. Secondary waves, they can travel only through solid, not through liquid but only through solid. So these are the different phenomena of these waves through which we can understand that what exactly these seismic waves can do. So here is a perfect diagram of what exactly the interior structure of the earth looks like. And here you can see that the top that is covered with the crust, that is 0 to 100 kilometer. Then comes the mantle that covers from 100 to 2900 kilometer. Then the core is basically also divided into outer core and inner core. So let's discuss about them in detail also. So according to some scientific researchers, structure of the earth's interior is fundamentally divided into three layers: crust, mantle, and core. The crust is the uppermost part on which we lives. The mantle is the middle part that is majorly made of molten state of rocks, and the core is the central part or the core part of the earth, and that is made up of nickel and iron majorly. That is also in solid form. The inner core is in solid form and outer core is in liquid form. So let's discuss more on this. Now the first one is the crust. So this layer is almost 8 to 40 kilometer thick and is the outermost solid part of the earth. So crust is the uppermost part of the earth. When the magma in the mantle area comes out on the surface, it is called lava, and as soon as it got out from this on the surface of the earth, it starts cooling down and gets solidified, and when it gets solidified, it starts to become a crust. And that is why the crust that we see all around ourselves is the part on which we lives and on which the all the people, all the habitant exist. So that the thickness of this part of the earth is approximately 8 to 40 kilometer thick, and it is the outermost solid part of the earth. Under the oceanic and continental areas, the thickness of the crust is different. The continental crust is about 30 kilometer and is thicker as compared to the oceanic crust, about 5 kilometer. The nature of the crust is brittle. Silica and aluminium are the major constituent elements of the crust, so it is also termed as sial. Sial is the region comprising the crust and the uppermost solid mantle and is a part of the lithosphere. Almost 0.5% of Earth's mass and 1% of Earth's volume are made of the crust. 3 gram per centimeter cube is the mean density of the material in the crust. The Conrad discontinuity is the discontinuity between the upper crust and the lower crust. So, first thing that we know is the thickness is approximately 8 to 40 kilometer, and at oceanic level and continental level this thickness is different. At continental crust, that is about 30 kilometer, is thicker as compared to the oceanic crust, that is about 5 kilometer. That is a simple thing. Crust is brittle, that we already know, because when the volcano erupts and it destroys the crust above it and comes out as a lava, so that clearly defines us that our crust is brittle in nature. Then if we talk about the silica and aluminium, so these are the most important constituents and that are found in the earth's crust, and we all know that if we talk about the elements that are found in the earth crust, then after the oxygen that ob- obtain the first position in terms of elements. After the oxygen, the aluminium is the most abundant metal in the earth's crust, and silicon is also one of the most abundant element in the earth's crust. Then Sial is the region comprising the crust and the uppermost solid mantle and is a part of the lithosphere. That is also another point. And if we talk about the density of the crust, so that is 3 gram per centimeter cube. Remember that the whole earth's density is approximately 5.5 gram per centimeter cube. And the Conrad discontinuity is very important because this defines that kind of a boundary between the upper crust and the lower crust. What is the difference? So lower crust is a bit of liquid state and solid as well, and this part of crust is just adjacent or parallel to the mantle, that is the molten part. So that is why there is a difference between the upper crust and the lower crust one. So do remember all these things. Now let's discuss about the mantle. So mantle is the portion of the interior beyond the crust. So when we go beyond the crust, we can found a state or the position that is called a mantle. Morovic discontinuity is a discontinuity between the crust and the mantle. It is also known as Moho discontinuity. So do remember that Conrad is between upper crust and lower crust, and Mohovic or Morovic discontinuity is between the crust and the mantle. The thickness of the Earth's mantle is near about 2900 kilometer. So do remember that mantle is the widest layer in the interior structure of the Earth. The mantle of the Earth occupied 84% of Earth's volume and 67% of the Earth's mass. So by the percentage of volume, it consists of 84%, and by mass it consists of 67%. Silicon and magnesium and the major constituent elements of the mantle, so it is called SEMA. So as in crust we have Sial, so in mantle we have SEMA. The density of the mantle varies from 3.3 to 5.4 gram per centimeter cube, and its density is higher than the crust. So we already know that the density of the crust is 3.3 gram, 3.3 gram per centimeter cube, and here we can see that the density of mantle is higher. The lithosphere consists of the uppermost solid part of the mantle and the entire crust. Rapti discontinuity is the discontinuity that is found in between the upper mantle and the lower mantle. So always remember that rapti is the discontinuity that is found between the upper mantle and lower mantle. The asthenosphere is a deforming region of the upper mantle. The thickness of the asthenosphere is in between 80 to 200 kilometers, and it is mechanically weak, highly viscous and ductile, which is found just below the lithosphere. Magma is erupted from the asthenosphere, and also it is the main source of magma. So do remember this thing. The asthenosphere is the layer over which the continental plate or lithospheric plates, the plate tectonic move. The mesosphere is the region just above the core, and it lies just below the lithosphere and asthenosphere, called the mesosphere. It is also a portion of the mantle. So core. So core is the innermost layer of the earth which is surrounding the earth's center. The mantle and the core are separated from Gutenberg's discontinuity. The core is also called Nephe because it is composed mainly of iron and nickel. The core is composed of 15% of Earth's volume and 32.5% of Earth's mass. The density of the core lies in between 9.5 to 14.5 gram per centimeter cube. It is the densest layer of the Earth. The core has its two sublayers, the inner core, the outer core. So, if we talk about first of all the asthenosphere, so we already know that this is the part of the continental plates or the layer over which the continental plates resides. And mesosphere is the region just above the core, and it lies just below the lithosphere and asthenosphere. So, mesosphere is also found in the atmosphere, but is also the part of the mantle in the interior structure of the earth. Then we have some relatable facts related to the core. So core is the innermost layer that we already know, and that just defines one thing, that it has the highest density. And Nephe is the material of which the core is made up of. So nickel and iron are the two elements. Then Gutenberg's discontinuity is very important. It is found between the mantle and the core. So I hope you are getting the remembering the things. Conrad is between the upper crust and lower crust. Morovic is between the core, between the crust and the mantle. Then in the mantle we have Rapti, that is between the upper mantle and lower mantle. And if we talk about the Gutenberg now, so that is between the mantle and the core. So remember all these points, guys. It is in a solid state which extends from the center of the earth until 5100 kilometers below the earth's surface. It believes that the inner core is composed of iron and some nickel. S wave rises from P waves, hit the outer core and inner core boundary. The inner core can transmit shear waves or transverse seismic waves. As compared to the rotation of the surface, the inner core rotates slightly fast. Barysphere is generally used to indicate the core of the Earth or sometimes the whole interior. The solid inner core does not have a magnetic field because it is too hot to hold a permanent magnetic field. Inner core density. The density of the Earth's inner core lies in between 12.6 gram per centimeter cube to 13 gram per centimeter cube. Lehman discontinuity is the discontinuity which is found in between the inner core and the outer core. So, if we talk about some of the important facts related to the core, so the inner core is composed 80% of iron and some nickel. That is why it is in solid state, and uh, instead there is a lot of temperature and pressure at the core. Instead of that, the core, that is the inner core, does not melt. And if we talk about S waves and P waves, so they hit the outer core and inner core boundary. The inner core transmit shear waves or transverse seismic waves, and if we talk about the density, so we can directly see that the inner core has the highest density in the whole Earth. And very important point, Lehman discontinuity is between the inner core and the outer core. So let's revise all the discontinuities. So first is the Conrad, that is between the upper crust and the lower crust. Then Mohorovic discontinuity is between the crust and the mantle. In case of mantle, we have Rapetti discontinuity, that is between the upper mantle and lower mantle. Then we have Gutenberg, that is between the mantle and the core. And after that, now we have the Lehman discontinuity, so that is between the core, outer core and inner core. The inner iron core is as hot as the sun, having a temperature of 6000 degrees Celsius, but the crushing pressure produced by the Earth's gravity prevents it from becoming liquid. The melting point of a solid will increase when there will increase in ambient pressure and vice versa. But ice is one exception. Increase the ambient pressure will lower its melting point in the case of ice. So, in case of other solid materials, if we increase the ambient pressure, that will also increase the melting point of the body or that solid body. So, instead there is 6000 degrees Celsius temperature, but still that part of the Earth is still in solid because of the high pressure that exists in that region. It is the core which is surrounding the inner core or the outer core, we can say. The outer core lies between 2900 km to 1500 km, 5100 km below the Earth's surface. It consists of iron mixed with nickel and along with the trace amount of lighter elements. So we can directly see that the core difference between the outer core and inner core, that inner core consists majorly of 80% iron. The outer core has a composition similar to the inner core, but it is liquid in nature because it does not have enough pressure to be solid. Dynamic theory. According to the dynamic theory, when the convection in the outer core is combined with the Coriolis effect, then it gives rise to the Earth's magnetic field. Till 9.9 gram per centimeter cube to 12.2 gram per centimeter cube is the range of the density of the outer core. The temperature of the Earth's outer core lies from 4400 degrees Celsius in the outer regions to 6000 degrees Celsius near the inner core. Now let's talk about the seismic discontinuities. So seismic discontinuities are that region of the Earth where, due to a marked change in physical or chemical properties, the seismic waves behave a lot different as compared to the surrounding regions. Moho discontinuity separates the crust from the mantle and it works as the boundary between the Earth's crust and the mantle. We already discussed about it. Morovic discontinuity was discovered by Andrija Morovic, who was a Croatian scientist. It shows a change in seismic waves velocity from the crust to the uppermost mantle. So when the seismic waves like P waves and S waves, P waves starts traveling through solid part of the crust towards the mantle, that is the liquid part. So we can directly observe a change in the velocity, and that is why this discontinuity is being defined here. Temperature, pressure, and density of the Earth's interior. So temperature, it is observed in deep wells and mines that there is a rise in temperature when increasing in the depth of them. So you must have seen in lot of films when the mining process is shown, they saw we saw that the laborers that is working in the mines are full of sweat, and a lot of heat is there in the mines. So that clearly defines that as soon as the depth increases, the temperature also increases. We have evidence for the temperature that increases when we will go towards the center of the earth. It is well proved by the molten lava erupted from the earth's interior. According to the different observations, scientists come to a conclusion that the rate of increase of temperature is not uniform from the surface towards the center of the earth, because it is slower at some places while faster at other places. The rate of increase of temperature will increase at an average rate of 1 degree Celsius for every 32-meter increase in depth. So, do remember this rate of change, as this can be asked directly in the exams. In case of a depth of the earth, 1 degree Celsius for every 32-meter increases. While the temperature will increase at the rate of 120 degrees Celsius per kilometer in the upper 100 kilometers, and also it will increase at the rate of 200 degrees Celsius per kilometer in the next 300 kilometers. So in the first half of the earth, as we starts moving down, so at the 32-meter increase there is a 1 degree Celsius increase in the temperature. Then the temperature will increase at the rate of 120 degree Celsius per kilometer in the upper 100 kilometers. So we can directly see that it is impossible for humans and human made materials and tools that they can go beneath at the center of the earth, or they can go very beyond in the depths of the earth. And also it will increase at the rate of 200 degrees Celsius per kilometer in the next 300 kilometers. So that is why we can say that it is impossible to reach the center of the earth or the depth of the earth. After the depth of 300 km, if going further deep, this rate of increase of temperature will have decreased at the rate of 100 degree Celsius per kilometer. So internal temperature at the center of the earth lies between 3000 to 5000 degrees Celsius. The temperature of the center is much higher due to the chemical reaction under the high pressure conditions. The material at the center are in solid state even in such a high temperature due to the heavy pressure of the overlying material. So it is somewhere around 3000 to 5000, and if we talk about the center, so it goes somewhere around 6000 degree Celsius. So do remember all these things about the interior structure. The pressure increases when going from the surface towards the center of the earth due to the enormous weight of the overlying material, rocks, sea, water, soil, etc. The material beneath the surface are melted towards the center of the earth at very high temperature, but these molten materials comes to have the properties of a solid, and they are probably in a plastic state. According to some scientific study, it is probably possible that in the deeper portions of the earth, the pressure is enormously very high, and it is nearly about 3 to 4 million times more than that of the pressure of the atmosphere at sea level. Now let's talk about the density. So density of the earth's layer also increases towards the center. It is due to the increase in pressure and the presence of heavier materials like iron and nickel towards the center. At the very center, the average density of the layers is nearly 14.5 gram per centimeter cube. It is also proved that the average density of the layers increases from crust towards the core. So that's it in this session. I hope you learned lot of things with relation to the internal structure of the earth. I will meet you in the next session. Till then, bye bye and thank you.